Automated fraud detection is a challenging, complex issue for many businesses, including insurance companies. And for us, it's a good opportunity to show you how powerful SV can be with just a couple of clicks. In this demo, we'll guide you step by step through a process of creating a virtual service that models and simulates features of automated fraud detection in health insurance industry. We use a version of the familiar claim processing REST demo, which is available on every machine with SV Designer installed, even in the free community version, so you can try everything with us. This health insurance app, processing claims for reimbursement, is our application under test. Say we are a part of a team responsible for developing the service. The live version of this service is used by healthcare providers' personnel to file claims for reimbursement. They use a GUI client to fill in a form for refund. Once a hospital administrator submits a claim, the claim processing service works with the two other services it depends on. Firstly, it uses the member account service to retrieve personal details of the insured person, and then it's supposed to call the fraud detection service that calculates the risk of fraud for the particular request. The major challenge facing our team is the fraud detection service isn't available yet. In fact, it's so complex it will be under development for weeks to come. The problem on our side is we need to integrate the service over the course of the next week, otherwise we won't be able to deliver on time. So our only option is to plug in SV and bridge this gap using a virtual service. And this is how it's all supposed to work. The health insurance app takes some basic identity info from the refund form and queries the member account service for personal details. Then it has everything it needs to contact the fraud service, which, based on values like the claim amount or the provided treatment, estimates the most likely type of fraud along with a risk score. Well, let's see how it may all look like in real. In your Documents folder, find SV demo resources of the following demo. Then click this command file, and we have the demo up and running. This is our claim processing service, the application under test, the member account service, which retrieves data about clients and insurance plans, and this is the fraud detection service. This one is real in case you want to play with it. So now let's file a claim using the refund form. Somebody has already pre-filled details for Mr. Hercule Poirot, requesting money back for some treatment at the dentist. The amount looks about reasonable, so clicking Enter Claim will make the services produce an approval right away. Having a higher amount, an additional approval will be needed. But now let's try to fill in something really suspicious, like this. Well, not a frequent procedure for males like Mr. Poirot, and voila! A potential fraud has been detected. By the way, did you know Mr. Poirot had a sister? Perhaps somebody is trying to charge her own procedure on Mr. Poirot's insurance plan, and perhaps it's because she has problems on her own. Well, this broken nose surgery, for instance, definitely looks suspicious. This amount hints at something much more expensive, perhaps a plastic surgery. Anyway, it's still way better than being Mr. Holmes, who, for his past offenses, can't even get a refund for aspirin without an explicit insurer's approval. Now imagine what happens if the fraud detection service doesn't exist yet. We'll have to build it from scratch as a virtual service. So let's start SV Designer and get the task done. By the way, in this folder we have some info to help us from the fraud detection team. There's a document with where the service should listen, the endpoint, and there's also a Swagger file specifying the service contract. In SV Designer, let's create a project. Let's call it Fraud Detection, since this time there will be just a single service inside called the fraud service. So let's add it. We'll use the Swagger file as the source of service description. Well, we could also do with a couple of sample messages, and in that case we would select the other option. Now press Next. Here, for the virtual service, we'll select HTTP Gateway, since it's less dependent on your machine settings. Now just press Virtualize. This is the home page of the newly created virtual service. Here, we can see where the virtual service listens. At this moment, we are ready to start describing service behavior, which is defined by service data models. There's always an empty one created for us by default, and this is how data models look like. It contains one or many operations for which the behavior is specified using one or many rules. The more specific rules are usually placed higher than the more general ones. These numbers mark their priority. Two special rules have been created for us by default. Currently, the learned rule is the highest priority one, but it doesn't contain any data since we haven't learned any because the real service is not yet available. We could safely disable it, since we don't need it, but let's do just the minimum that's necessary, which is mostly reviewing the default rule. The default rule can't be disabled, and it is always the lowest priority. That's because if the service doesn't know what to respond with, it needs to respond anyway with something really general. Data model rows have a request part and a response part. Before we dig deeper, let's select columns that are of interest to us. So firstly, we'll work with JSON input. For now, let's hide various HTTP input parameters, and on the other hand, display the post data containing all the interesting values we'll use in fraud detection. Similarly, for response, we'll work with JSON output. We are not interested in HTTP output parameters, but we need to work with the fraud scoring results. And let's also display functions. This basically means whatever comes in a request, do respond by simulating these values. If your client application doesn't fail on these, fair enough, you don't have to change anything. But for our claim processing service, we'll need to make a couple of changes. Inside the default rule, there's always one row per response type. Here we have two. One for response with no content, and the other one for a JSON response. Since our claim processing service would probably fail on empty response, let's prioritize the JSON default response over the empty one like this. You could also use drag and drop. And now let's set up some meaningful default JSON output. In response, we'll need to produce the post data. We'll also need some default fraud type. Okay, check in the documentation. This seems like the most general type of fraud. And for start, let's report zero risk of fraud by default. Well, and perhaps it would be also nice to always copy the claim ID from request to response. So select the copy from function. This dialog informs us we need to select the source column, which is this one. Okay, and now let's keep the rest of the fields with these auto-generated values. The client application won't be failing on these, and we'll handle them later. Now let's save, return to the home page of our virtual service, and switch to simulation like this. Now let's go back to the refund form and try to send the claim again. Well, perfect. Mr. Holmes got his aspirin since we currently always report zero risk, but at least we have established connectivity with the virtual service, which gives us some time and our developers can start coding some basic integration stuff. Meanwhile, we'll work on making our service behave more realistically. As we already know, Mr. Holmes is a frequent offender, so let's perhaps create a rule for frequent offenders. Let's add a row. Display it in row detail. And now, if the social security number is that of Mr. Sherlock Holmes, report it back as repeated offender with risk score, say 20. We can safely ignore this field, as it will be populated by the default rule by copying the claim ID from request to response. Here, in a higher priority rule, we have no reason to override this more general behavior. Let's save, restart the simulation, and try get Mr. Holmes some aspirin. Seems for Mr. Holmes we have the desired behavior, but it's still relatively dummy. In the next part of this video, we'll learn to use some of the more advanced custom data rules.